All right. So let's start delving into the Bitcoin technical design, and we'll basically work it out element by element together. So that was just a very high level introduction. So now we're going to start the technical discussion. So this technical design was developed by Satoshi Nakamoto, who wrote a very beautiful white paper on Bitcoin. It's in the syllabus, you can read it. It's actually super short and to the point. It's super dense. I mean, for such a short paper, pretty much every sentence carries a lot of meaning. So it's really interesting to see how, he was able to write in a very succinct way, but yet convey a lot. No one knows who he is. People have all kinds of guesses. So it's mostly an online presence. And his name stands for Clear Wise Medium. So it's a Japanese name, but it's most likely a pseudonym that stands for Clear Wise and Medium. And all we know is that he's very rich because he has a lot of Bitcoins. He was one of the early miners, but he hasn't changed yet as to our knowledge. All right, so in order to design the technical protocol, we need to, and to replace the banks, we need to replace the mechanisms that banks provide to us in a different way using cryptography. Okay, so we can no longer trust any one organization, so we have to trust math and cryptography. So a bank provides to us identity management, transactions, and prevents double spending. So we will have to, provide equivalents of these using cryptography. So the question is, how can we enforce these properties using cryptography? And there will be two components to the Bitcoin design. The ledger, which will be a publicly visible, append-only and immutable log, and we'll discuss how to construct it. Again, it's a really nice combination of system security and cryptography. And the second is to have transactions implemented by cryptography. So we'll start with the second one, cryptographic transactions. So for now, we are going to assume there's a ledger. Okay, so a ledger is a public log that is append-only, everybody can add to it. Let's say it has an owner that can check whether what you add is valid according to some definition of valid. It's immutable, people can't change the history. They can only add if they add things that are valid. And everybody can see what's inside it, okay? So for now, assume that we have this ledger, and then we'll see how to design it, okay? We'll focus first of all on designing cryptographic transactions, assuming that we have this ledger. Okay, so the very first question is, how can we give a person a cryptographic identity, right? We need some sort of identity notion. Banks have it, so we need it too. Any ideas how to do that? Yeah, so Justin Cheng is saying signature. So signature for identity or signature for a statement? How do I what is actually the identity? Yeah, so Nile is saying private key and UID. And then Shana is saying generate random key. Gloria is saying private public keys. Caroline, you have a key. And yeah, exactly. So what we really need is a public key, right? Public and private key pair. Now, the public key is the identity. Okay, the user is referred by the public key. We can't have a secret key with the identity because, people know your identity. They refer to you via your identity. So it can't be a secret key. It's a public key. Now, what proves that you are the person with a public key? The fact that you have the secret key. You can sign with that secret key, which proves that you have it. And so you are the person with that public key. Okay? So the identity is the public key, and the secret key is what proves that you own that public